Thank you for joining us for this webinar. We're the BV-BRC team, and we're going to tell you all about what we've been doing to respond to the current H5N1 situation and some of the tools on the BV-BRC that you can use to analyze data, and just kind of give you a quick overview on how we can help you do your research. So the goal of our discussion today is to talk about what is the BV-BRC, a brief overview on H5N1 in 2024, overlooking the BV-BR website, showing you about a BV-BRC workspace, our specific outbreak page, how to search for data in the BV-BRC, tools for analysis, our sequence submission tool, and then hopefully there's some time for conclusions and questions. I do want to be clear that we're probably going to go very fast over all of this, but that doesn't mean we don't have much more in-depth versions of it in various places. And so we'll send out the presentation afterwards, and that will have links to more detailed versions of all of the tools for analysis and how to search for data, how to kind of get oriented in more detail. So the BV-BRC's mission is to provide a one-stop shop for data about human pathogenic and related bacteria and viruses, and have a bioinformatic resource that helps support that. So we have a lot of data and tools for analysis that help support you to do your research. Our pathogen database grows every day, and you'll see just specifically in H5N1 how that has been growing. We annotate the genomes when they come into our database and annotate and curate the metadata to make it as useful as possible. Our analysis services run on high throughput computing services, so you can do all of your analysis right in the browser and know that it's getting run on high computing power. We have a lot of different visualization and analyzation tools. We have rapid outbreak response, which is what we'll be talking about today. The workspaces are private for you to use, so you can share them similar to a Google Drive folder, keeping it private and fair for you. And we also have what we call super user access, so you can be able to download lots of bulk data, and we have tools and documentation to help support that. Then we do outreach and education. So if you want to learn more past the videos that we've already done, or potentially have us help you host a workshop, that's something that we can do as well. We have over 50,000 registered users and 25,000 unique visitors a month. And our user base is diverse from academia to pharma, clinical researchers, and so on. So hope that if you aren't currently a BV-BRC user, this might inspire you to become one. Our services menu has gotten a little bit of a change if you're familiar with what that looks like. So these are all of the services that we offer, and something that might have been on one column before might have moved over. So just look a little bit closer. If you think your favorite tool went away, it probably didn't. It just might have moved a little bit. But today we're going to talk about the annotation, the tree tools, Metacats, MSA, sequence submission. We have time, the subtype conversion, subspecies classification, and the main focus is on our outbreak tracker page, and that specifically the influenza H5N1 page. But we also have kind of deeper into our data. You can see multiple sequence alignments doing the analysis. We have surveillance data and protein data also that is accessible. So I touched briefly on what is a workspace, and this is your personal dashboard within the BV-BRC. Once you get this presentation, if you don't already have a workspace, this will send you to the page to register. And it allows you to add information from your device and then internally from the BV-BRC. So if you've run a lot of sequencing data and you want to put that onto the BV-BRC so you can analyze it, but so it stays private to you. That's where your workspace can help you do that. And there's personal, shared, and public, so you can keep it for you or within your lab group or with collaborators around the world. You control your own data, so we don't see it or do anything with it, but you have the ability to share it with who you'd like. So thinking about the current H5N1 outbreak, we know that influenza is a highly contagious respiratory illness, and since 2020, there's been an outbreak of H5N1, specifically the 2.3.44b lineage, and that's spread mainly across migrating birds all around the world. And there have been outbreaks that have spread to other places like North America and South America in 2021. Then 2022, other animals like mammals began to be infected, and there have been 6 human cases of H5N1 since 2020. But then now in 2024, concerned because there's new cattle have become a host, and then that transmission to humans. So that's really what prompted the BV-BRC to do a deeper dive into our outbreak response. And so we went from 2022 having all of these hosts, then these novel hosts of cattle and transmitting to humans. And so the BV-BRC has been monitoring and responding. Just to kind of give you an overview of how we handle our response. Up until a couple of months ago, we would share relevant H5N1 news or just relevant outbreak news in general. Then we've begun working with the USDA and other agencies to help submit sequences to GenBank. So that's our sequence submission service that I'd be happy to help you do, and April will talk about towards the end of the presentation. We've generated preliminary phylogenetic trees and then continue to update and refine those. If you are a BV-BRC user, and on our mailing list, you would have gotten our newsletter last week, and that at the last page of that included an infectious agents report. So this is something that we've prepared to just bring information together. And then finally, we created the outbreak pages, which is our next topic for discussion. So before, just a quick overview on the outbreak pages. So there's an overview page with broad level information, news and publications that are updated in real time, phylogenetics, which Christian will go into a lot more detail about. We have data linking out to different resources, and then just resources that we've compiled, and commands to use the bulk data download on the BV-BRC. So I've talked very quickly and a lot about the BV-BRC. This is what it looks like on the homepage as a logged in user. If you don't have an account already, then here you would have something that said register now. We wanted to make sure that our users knew about these outbreak pages, so they are right here front and center on the website, but they're also accessible under the tools and services menu, which I showed you a few slides ago. So you can either click it here or here. So that will land you on the outbreak overview tab. And so this is just some of the information that we've compiled thus far. We have awareness reports, and those link out for you to use. I'll guide you to the right side of the screen where you can see the news, and this is updated in real time, and curated to be high quality sources, so should be able to trust what you find here. We also have some recent PubMed articles that are also curated in that way. This map is generated from data from the CDC, and it says it's updated as of May 15th. Nothing has changed since then, so this is still up to date. Then we have some background on influenza A virus, taxonomy, disease information, and epidemiology. I'll hand it over to Christian to talk about the phylogenetics. So,
yes, can people hear me? Okay, so yeah, so we have we calculate one gene tree for each of the 8 segments, and our goal is to do that once a week. So we have a certain base sequences which are in there, which are kind of like older sequences to give the tree a context, and then we every week when new sequences become available, we'll add them to the tree, so they're likely to grow over time. And that might also mean that it could be in the future that maybe they will get too big and we have to do some kind of clustering. But for now, our goal is to include all the sequences from 2024. And as I said, there's eight trees, for each segment. And how they're calculated is as follows. As I said, we have for example, for this this week, May 21st, we have about 450 sequences, where about 150 are older and 300 are from this year's outbreak. And then we use a MOFT program to calculate the multiple sequence alignment using the most accurate options for people who are familiar with this program. And then currently I'm using RexML NG using the GTR model to calculate the trees using 4 gamma rates and with 100 bootstraps to assess support. And here I have to say that, of course, within the new sequences coming out, because they're extremely similar, so the support is really low. There's basically no structure in those, but there's very good support when you go back to the older ones. And then we use a custom software to decorate the tree with various metadata. And now if Anna could actually show the actual an example tree. So here is how it looks. And if you starting on the left side, so there you have a couple of buttons where, for example, it says node name. If you turn that one off or click on it, click on it. Oh.
Okay. There we go.
Okay. So then you can use the other buttons to to compose your own name. So, for example, if you want to use just a year for the name or the host, you can do that. So you can compose your whatever is in there. So that's gives you control over that. And then a little bit below that, we have you can zoom in various directions. You can zoom in horizontal and vertical. So you can, because now it's high, because it's about 400 sequences in there. So if you zoom in and zoom out, you can make it bigger. Maybe like that. And you can use using the mouse, you can move around the tree itself. So like that, yeah. And then you have now if we go to the right side, this is in a way that's the most important one. This one controls what kind of data is being visualized. So you can visualize various things, for example, as colors. For example, the year or the host. So you can show various information, and then on the left side there's a legend for that. And what many people don't know, if you click on the color buttons, you can change the color to whatever you want. So like that, you can select the color, so you can colorize it in a way you want. And then if maybe you could put all the visuals on the right side, if you put it to default.
How do I do that?
You have to go to the menu on the right side, and where you just select default for all of them. Okay, so because I want to show you there's also a search function, which is on the left side on the search. You can search two different things with two different colors. For example, if you type in here cattle, it will colorize all the cattle. When wherever you found the word cattle, it will colorize it green. Or yeah, like that. So you can also search like flexible. And then the final thing I want to draw attention to is if you're clicking on a node, you can do various things. You can do you can go to a subtree. So that means it only shows you the subtree emanating from that node. Or very useful, in my opinion, is if you go there, you can download the sequences which are associated with that subtree. So all the sequences actually, it's part of the tree, and you can download them and do whatever you want with them. And the final thing is something which will be added next week, which is not here this week because the software is a little bit older. But starting next week, you will also have the ability to directly link to GenBank. So you can go any external node, highlight it, and then it provides you a link to see that sequence within GenBank. So, but that's, as I said, that's the current version doesn't have that. And you can also, yeah, that's a little bit ugly, unfortunately. You have to go to the close button.
Sorry about that.
No problem. Yeah, it's a little bit slow because it's, I guess, running the presentation.
Yes.
And anyway, so that's basically the tree tool. And if you have questions, I'm happy to answer them via email or other means. And as I said, we're planning to update those trees once a week, so they will keep growing. There will be new sequences in there. And yeah, if you have any suggestions or questions how to run the program, I'm happy to help. So
and we'll talk about how you can generate your own trees. These are just for all users to quickly be able to have access to them.
Correct, yes. And those trees will use the same tree display tool. Okay, I think that's it from me. So
did you
oh, here's just I just summarized one more time. So the highlights is, yeah, you can visualize colors and shape. You can use the year, or you can use a host, which is things like cattle or chicken. We also have host groups, which are like avian, non-human mammals. You can colorize according to region, which is things like North America, Southeast Asia, country, which is self-explanatory. State, currently we only have US states, but in the future, we might also have Canadian states. And then for segment 4, we also have the H5 clade annotation, which of course for all the current outbreak is the same. It's 2344B, but who knows, maybe at some point a new clade will be declared, and then you could see that. And as I already noticed, many people don't know, you can change the colors if you want by clicking on the rectangle or on the legend. And on the next slide, I just have summarized the visualization one more time. So we have a flexible search. You can search entire words. You can even use a regular expression. You can collapse by feature. There's zoom in and zoom out. You can compose your own node names with whatever element you want from a selection of years or regions. And by mousing over nodes, detailed information is revealed. And you can click on node to get more information. You can move to a subtree. You can collapse and uncollapse. You can reroute. And as I said, you can download the DNA associated with either a node or a subtree. And in the future, there'll be a link to GenBank too. So
wonderful.
Thanks.
So just to go back through the other tabs that are on the outbreak page. So on our resources tab, we link to BV-BRC resources that you might want to use for your analysis, and then some other curated resources from good sources like the USDA and WHO, and the flu board. The last tab is our command line tools. So these are for your bulk data downloads. We have a complete guide to installing the command line interface that you can click on here. So these are assuming that you've done that before, but the commands that you would need to run to download that data. I'm more happy to give you any more information. That's something that you're interested in, check that out here. I brushed over the data tab because the next thing we're going to talk about is how to search for data in the BV-BRC. But we do have links to the SRA and NCBI virus. This outbreak genomes kind of stops you from having to know all of the searches that I'm going to go through now with you, but that will bring you to a curated H5N1 2024 North America, all of the genomic data that we have for that. But when we're thinking about searching for data in the BV-BRC, there's really 4 main ways of searching. So on the home page, there's this giant search bar, and you can put in whatever keywords that you might be interested in. Then there's an advanced search option, and I'll go over these in a little bit more detail as well, but this allows you to search on things like taxa, genomes, strains, visualizing our surveillance data, and again, we have a much more detailed talk about searches, but this is one of the ways. And then under the organisms, you can search by a specific viral family or a featured virus like influenza A. And then when you're on a page, this search bar will come up and you can search in a little bit more detail. So when we're thinking about what that looks like on the BV-BRC, if we start with viruses or searching H5N1 here, that could be an option. My favorite way is to go influenza A virus. Then this format is mapped and the same for all viruses. So, and really all data that we have in the BV-BRC. So it's a lot, but once you understand the way that it's all related, it should be pretty easy to move around. So we have an overview page, and that overview is about these genomes specifically. And so that's all of these tabs are related to the data that you have sliced. So we see that we're starting at viruses and then going down the taxonomy. And so under influenza A virus, you could then go just specifically to H5N1 and click there. And that would pull out that subset of genomes and the related features and protein structures and so on. But I'm going to go over to the genome tab so that you can understand our filters. So they don't automatically apply. So you just need to hit this little filter button, and you have the capability to move this up and down depending on your interest. And you can also add or remove filterable columns. So these aren't all of the ones, just ones that might be the most relevant. I just added H5 clade because that could be interesting. And you can remove ones so that you can see what you're interested in. So if we're interested in the current cases of H5N1 in North America right now, we could filter on geographic group, North America. And so that has put this filter with the yellow bar, but it's not applied because we still see this all influenza number, though the number that's shown in the database is less. So you can sort of trial a filter, and that's why you also see these other regions. But we'll apply that filter, and then that will mean that you only have those from North America. The same thing can be done by year. So you can scroll all the way down to 2024 or you can put in, and then that will only show you to 2022. So if we do min 2022, then that quickly brings you down there. And then you could select all of those if you wanted, but we'll just stick with 2024. So then now we have 30,000. So I'm going to apply that. And you can see here under segment that we have this for all of the segments. So just knowing that you'll have 8 times for a specific ID to get all of the segments. So then we'll filter down to subtype H5N1. Apply that. And now you can see the different hosts that these 2024 H5N1 North America samples are from. And so it's important to see here that this 2,411 is matched here. So that means that you're only looking at these. So you're not going to have some other random thing added in. And we have the H5 clade. So we are, of the 2024 H5N1 samples from North America, all of the ones that have been typed are the 2.3.44b. And you can visualize that by having under type info, adding a column for H5 clade. You can sort on these. And so then that will be all of the ones that are currently have run through a subspecies classification pipeline. That's something that we do as we bring in data. So there might be a tiny delay of a day for that, but that is a service that the BV-BRC is providing to you, is getting that clade data up to date and on the records. Then if you were interested in this data set of these 2,411 genomes, you could create a genome group from that. I'm just going to do segment 4. So we're comparing the same sort of thing. So you can select on a segment as well. And then you can create a genome group from that. If you click on, if you want all of those 303, you click right at the top. If you only wanted the first 10, you can press your shift and select a whole subset. But then you can put these in a group. So if I have all of these 303 selected, I go over to the green bar and hit group. This can either be put into a new group or an existing group. In my genome groups, do H5. And then add those. And so now that's in my genome groups folder in my workspace, which you can get here. But again, we have other presentations where you can find that in more detail. So now that we have these selected in the genomes here, you can look at associated features that are just in these specific genomes. So you can get the features and proteins that are related to those genomes, and run analysis on, maybe if you're interested in the HA protein specifically, you could only have the HAs from those 303 genomes. And so that is why the filtering of data is really good. So you'll see 1,205 here. That's because we have more than one protein associated with each of those genomes, but that is a way that you can, if you sorted on product, for example, then you could get all the HA1 for those 303. So that's a very quick explanation of filtering and searching for data on the BV-BRC. You could also search up here, for example, on the advanced searches, and then that will pull up those of that subtype. If you wanted to, this method makes more sense to your brain. You have a lot of options for different ways of thinking about getting to the data, but it'll all bring you back to the same place. So the next thing we want to talk about is tools for analysis. So we'll start by talking about the viral tree service. And so this is when you're thinking about building your own tree. They can be built on nucleotide or protein inputs, and that gives you flexibility. We have fast tree options and 2 maximum likelihood algorithms. And so this gives you, depending on how much time you want to spend doing your analysis, different options or the specificity that you're looking for. So these are under our phylogenomics section under tools and services. So the viral genome tree, it can have that option for the different parameters for the tree, different models. If you want to add metadata visualizations, then you can make sure that those are applied so that when you're generating your tree, you can see the metadata that you're interested in. You can start with a genome group. So that genome group that I just made, can put that here, and then that'll bring that down just by pushing this little plus there. And then once you designate an output folder, it can run that job. So when you're using a BV-BRC tool, it'll show up in this job list. And so it'll take a second once a job started running to show that it's running, but that's a place that you can see those. We also have gene and protein trees. So this is from specific genes or proteins. So had I taken that list of genomes and gone to the HA1 protein, then I could have used a feature group for that. But you can also bring in your own data. It doesn't have to be the publicly available ones. So if you have a aligned FASTA or an unaligned FASTA that you want to generate a tree from, feel free to use the BV-BRC for that. You just need to put that data in your private workspace. I'll let Christian talk about the subspecies classification tool really quick, if he wants.
Yes, I'm just turning on my microphone again. Yeah, so we also have a subspecies classification tool which works for a variety of viruses, including influenza H5, and it's based on segment 4, the hemagglutinin segment. And how it's working is it uses the reference tree you can see on the right side, and it uses a program called pplacer, which basically places your query sequence on all possible placements, and then evaluates the most likely placement or placements, because if there's uncertainty, there could be multiple placement. And then it uses a tool which we developed called Cladinator, which kind of makes an interpretation of the placement, and then it reports the result back to the user. So you don't actually have to look at the tree, so the program looks at the tree for you. But if you want, you can still see the tree. And here the important thing is that if you're working on influenza, you have to use the right segment, in this case the segment 4 for the analysis. And in the future we will be a feature into the tool, so it gives you a warning if you're using the wrong segment. But currently that's not there, so you might get the wrong result if you don't use the right segment. But in the future there will be a strong warning. You know, your sequence is likely to be wrong, but it's not currently there yet. But otherwise the tool works it works reliably. And one advantage of this approach compared to like blast searches is that if your query sequence falls out of any established clade, it will tell you that. So it's not just using the nearest clade. It will say it could not be assigned, or it's between two clades. So I think that's an advantage of this approach, and it's fast. You can analyze hundreds of sequences at the same time. So you don't have to do it one by one. You can upload a FASTA file of 100 sequences in there, and it probably takes maybe 10 minutes or so, and you get the result for each query.
And so just for example, I took this red-tailed hawk hemagglutinin gene from 2024, put the sequence in a tool. I could have started with a FASTA file too. Then I ran that job, and this is the output when you run the job. You click this little view result, and you'll see that it was classified as 2.344B. And then you can see that tree and where your query sequence. The next tool I wanted to touch on is our Metacats tool, and this is a metadata-driven comparative analysis tool. And so that looks at positions that are significantly different, so base pair positions that are significantly different between user-defined groups of sequences. Now, it's important to note that there might be biases due to covariation, codon-based biases, differences in genotype, geography, time of isolation, and other things that might impact statistical assumptions. But you have the ability to compare two different groups. So maybe it's sequences from 2024 versus 2023, or sequences from North America and Europe, and then see if there are any statistically significant base pair changes. And so we have tutorials and more details about this, but this is a great way to do some statistical analysis of your differences. And that can be found under protein tools. So you set your parameters, your input, what metadata feature that you're interested in searching on, then you can set that. And this is a good time, since this one's has a lot of things that you need to understand. Our quick reference guides and tutorials are here to help you, and those you can just click on, which brings you to our doc site. And so that goes through the information that you might need to understand. We have these for all of our tools and services. But if you ever have questions, you can reach us at help@bvbrc.org, and we'll give you more information. We definitely don't want our users stuck. So if whatever tool you're using, you have questions, please reach out so we can help support you. Some services to run through: we have FASTQ utilities services that can help you align, measure base call quality, trim FASTQ read files. We have a viral genome annotation tool that uses the Vigor4 databases to add annotations to your assemblies. And we have multiple sequence alignment and SNP variation analysis. So if you're ever on the doc site, the best way to go is just BV-BRC home. You can also get to the doc site by under help. But looking at where those tools are, FASTQ utilities is under utilities. Our annotation service is here. So you would just submit your config file, then annotation for viruses. You can put in influenza viruses, and then label it, and then run annotation on that file. Again, quick guide and tutorials for annotation. The last one I said was MSA, which is under protein tools. Can start with unaligned or aligned sequences coming from a variety of sources. Then that will run the same sort of job. And some of our services even have instructional videos guide linked to them. So that's denoted up here or here, and that'll bring you to our YouTube. But here you can see all of the BV-BRC videos that go through on the services. And like I said, longer ones for how to search for data and submitting sequences. So feel free to check those out on all of our videos. The next tool that I'm hoping April can tell us about is the HA subtype numbering conversion. Will, are you able to chime in about that?
So the goal for the HA subtype is to take an influenza HA protein and then convert their existing HA position numbering to a different HA numbering scheme using the David Burke and Derek Smith method. It uses both the sequence and structure information to propose the position of functional equivalence across different HA subtypes. There's several different steps. The first step is the user input, then the blast, then it does an MSA, mapping, and then the generating the results.
And so that is under the viral tools section. So you can find that here. You can see the conversion sequencing schemes. Let's see. So next April's gonna continue on about sequence submission.
The goal here is to validate and submit virus sequences to NCBI GenBank. There's two main steps in sequence submission. The first step is the validation and then the annotation of the sequences. There's 4 steps in the sequence submission tool service. The first one is to specify the parameters, which include submitter information, a metadata file in CSV format, and a FASTA file. The second step is to click on submitting the job. Then when the job is finished running, you get 13 output files, including a sequence validation report that has the annotation from Vigor and Plan. And then the last step is to notify the BV-BRC team that your submission is ready to be processed. And you want to switch to the service? Yeah.
Yes.
But this is where the submitter information goes. It asks for your institution, your consortium, your address, and then it asks for a sequence FASTA file that can be pasted there or that you can upload from your device, as well as the metadata file in CSV format that can be uploaded or it should be uploaded from your device or from the BV-BRC workspace. And then you select your output folder and an output name for your job. I think it's really helpful to go to the tutorial. Can you click on the tutorial, Anna? It describes every step more in detail. Here you see how to access the service. And then it describes all of the fields for the submitter information, how to upload your file, your metadata and FASTA file. And then how to check the status of the job once the job is completed. Here it describes all of the output files in detail. And then it goes over the annotation that I described from Vigor and Plan. And we also have templates for the FASTA and the CSV, and then the Excel file at the top describes all of the metadata fields in more in detail, like the limit of the characters, or what is isolation source, what is the host, and so on.
Not sure my multiples sharing will pull that up, but you can view these files to make sure that you have everything that's set, and they can be downloaded here. So anything else about sequence submission?
I don't have anything else to add. We're always open to helping formatting CSV files or the FASTA files if anyone needs help with that. I went over it really fast, but the tutorial details have very detailed information for everything.
So to quickly whirlwind recap all that we talked about, we went over what the BV-BRC is, a very fast demo of that, some influenza H5N1 background, a further description of the BV-BRC site, some tools that you can use to support your research, and now gonna conclude with any questions. And again, I'm gonna share this with you all with these links, but these are ways to just dive deeper and get some more information. So we have the Back to Basics webinar series that covers searching for data, analyzing viral genomes, building trees, sequence submission, and analyzing protein data. The help documents that are for all the tools, specifically the Archaeopteryx help documents so that you can get the most out of that tree visualization. Please feel free to keep up with everything that the BV-BRC is doing. So you can follow us on LinkedIn, Twitter. Make sure you're on our email list so you'll get our newsletter. And then also have our command line documents. The BV-BRC would not exist without the superstar team. And I'm going to highlight just the effort on the JCVI team side to get the outbreak pages up for the community. Really a lot of hard work went into that, so really thankful for all of that.